Okay, so let's continue talking about how atoms absorb and emit light. So here is our original picture here of the energy levels that an atom would have. And on each energy level, a certain number of electrons would be allowed to live. This is a different way of looking at it. So here is the first energy level. Now the nucleus would be in the middle of this thing. So here's the first energy level, the second energy level, the third energy level, and then the fourth energy level. So it's the same picture as this one, but we use rings in order to describe it. I also said that if electrons absorb energy, they're going to go up. So they're going to try to jump up in their energy levels. And then when an electron comes back down, it's going to emit energy. So electrons, when they go up, absorb energy. Electrons, when they go down, they're going to emit energy. Where could this energy come from? You could take an atom and you could shine light on it. So that would be light energy coming in and then hitting one of these electrons. You could also use heat to do it. You could also use some kind of a chemical reaction to do it. But one way or another, we're giving energy to these electrons and then observing what are they going to do. Okay, now one of the critical things from quantum mechanics is that when these electrons jump, they have to absolutely positively, this electron could jump to this level if it wants, and it can jump to this level if it wants, and it can jump to this level if it wants, but absolutely positively no, can it jump to right there. That would be a forbidden jump. And likewise, it can't jump to, let's say, to right there. That's a forbidden jump. It can only go from one energy level to the next. So it cannot go halfway. It can't go 99% of the way. It's an all or nothing thing. So in order to understand this, think about stairs. So here are some stairs, and let's say that each stair is 8 inches tall. So what's going to happen if you raise your foot 10 inches and you try to step onto the stair? You can't do it. Not until your foot comes down to 8 inches. Well, what happens if you raise your foot 6 inches? You're going to trip. So again, you cannot step onto a step unless you're raising your foot exactly 8 inches. And so inside the atom, the electrons are going to jump from one energy level to the next. Now it can jump 2 energy levels if it wants, but it cannot jump in between the energy levels. That's going to be forbidden according to the laws of quantum mechanics. Now when it comes back down, so let's say that the electron jumps up to here, and that takes a certain amount of energy. When it jumps back down, how much energy do you think it gives off? Exactly the same amount. So whatever energy went into it in order to raise it up one, that same energy is going to come out when it comes back down. All right, what about if we go up 2 of them? So let's say that we go up 2 energy levels and we want to come back down. We can do it 2 different ways. We could jump all the way back down, and if we did that, that's going to give off exactly the same amount of energy that went in. But can you see a different way? You could jump from this energy level here, you could jump down to here, and then from here do what? Then from there, then you could jump down. So you could jump down in 2 steps instead of jumping all the way down in one big step. Each jump produces its own unique color. And so in this picture that I've got right here, it shows what color of light would be produced if you're on this ring. And let's say that you jump all the way down to that ring. Well, that's going to produce a certain color of light. But on the other hand, if you jump from here to here, that's going to produce a different color of light. So when we look at the light produced by atoms, we get an atom excited. So the electrons are jumping up and down. We look at it through a special device called a diffraction grating. Later, we're going to talk about what diffraction is. But in a diffraction grating, it's a piece of plastic that has a whole bunch of lines scratched into it. And then when light goes through it, it spreads it out into the rainbow of colors. So look at that black rectangle, and do you notice it's got certain colors in it? But it's mostly black. So each of the colors in that black rectangle are the colors that are being emitted for various jumps. What's the black part? What does that represent? You can't see anything because those are forbidden jumps. Maybe the black in this part over here, maybe that would represent something like this, where it's going halfway, but it's not, you can't do it. So only certain colors of light are going to be emitted by an atom. And every atom is unique. So every atom has a different number of electrons, so it's going to produce a different pattern of light when it's excited. So you can see there's the colors produced by hydrogen, the colors produced by helium, and so forth. Every element is unique. And so we can use this, so if we've got some kind of a chemical that we want to know what's in it, we can heat that chemical up to the point at which the atoms are jumping up and down. We look at the colors of light emitted by that. We run it through a computer, and the computer can tell us what are the atoms that that chemical is composed of. So pretty impressive. All right, so let's take a break, and when we come back, we're going to talk about the human eye.